right? So in bacteria, in purple sulfur bacteria, H2S is oxidizable compound to reduce, or I am writing in easy language, oxidizable compound. Oxidizable compound means what? Hydrogen donor to reduce CO2 into carbohydrate. Whereas in higher plant, H2O is oxidizable compound. That is hydrogen donor. Got the idea? To reduce CO2 into carbohydrate. Try to understand it with the equation. So he told is 2 HCO2 react with 2H2O and it give rise to, and 2H2A I am writing before, 2H2A, it give in presence of light, getting the things or not? It converted into CH2O plus H2O plus 2A. These are the empirical equation of photosynthesis given by Van Niel, and here 2H2A is what? Oxidizable compound. So A is sulfur in purple sulfur bacteria, and A is oxygen in higher plant. Are you getting the idea or not? So higher plant is what? H2O. Higher plant taking H2O. Sulfur bacteria taking H2S. That's the reason I wrote A is sulfur in purple bacteria and A is oxygen in higher plant. So H2O or H2S. Source of hydrogen is hydrogen sulfide in which one? Got the idea? Is it clear in the mind? Now we are moving ahead. Give your attention. Based on these observations, Van Niel gave a very important finding. What very important finding Van Niel have given? Ki either in bacterial photosynthesis or photosynthesis in higher plant, who is common? CO2 is common. CO2 is common. So when photosynthesis occur in plant, so CO2 react with 2H2O, give rise to CH2O plus H2O plus oxygen in plant. But in bacterial photosynthesis, when CO2 react with 2H2O and not it 2H2O, it is 2H2S in bacteria, sulfur bacteria, CH2O is forming, plus H2O is forming, plus 2S is forming. Who is not evolving? oxygen not evolving. So in bacterial photosynthesis, oxygen is not evolving. And during photosynthesis in plant, oxygen is evolving. This is a major difference he find during photosynthesis when he compare the photosynthesis of purple bacteria and plant. What major difference he find? What major difference he find? Oxygen evolved during photosynthesis in which one? Higher plant. Oxygen not evolved during photosynthesis in which one? Purple sulfur bacteria. His mind strike. He told people are saying O2 coming from CO2. Why CO2 also present in bacteria? Bacteria is also taking CO2. Why O2 is not coming? And he gave a conclusion. It means oxygen not come from CO2. If oxygen came from CO2, who is present in bacteria also? Who is not coming? Oxygen is not coming. It means oxygen evolved during photosynthesis came from water. In sulfur bacteria, who is missing? Water is missing, hence oxygen is not coming. And he changed the thought process of the people. During photosynthesis, oxygen who evolved not came from CO2, that came from water. So what he concluded? During photosynthesis, oxygen evolved came from water. Understanding the idea or not? And as he told, reaction of photosynthesis change. Now the modern reaction, new reaction is what? 6CO2 plus 12H2O give rise to C6H12O6 plus 6H2O plus 6O2. NCERT also asked a question. Why we are taking 12H2O? Why we are taking 12H2O? There is a reason. How many oxygen is evolving? 6 oxygen. And for 6 oxygen, how many O2 required? 12 O2 required, and here in 12H2O, how many oxygen is there? 12 oxygen is there. Got the idea? Understand? Is it clear? Now one student asked a question, all photosynthetic bacteria evolve sulfur, sir? No. Answer is not. It is only evolved by purple sulfur or green sulfur bacteria. Not evolve oxygen. Otherwise, blue-green algae is also a bacteria. They evolve oxygen. Cyanobacteria evolve oxygen. Purple sulfur bacteria not evolve oxygen. Are you getting the idea? Is it clear? So here bacteria means always what? Purple sulfur bacteria. Don't confuse. It is purple or green sulfur bacteria. Is it clear in the mind? So these are the findings of Van Niel. Now we are going to talk about, so why they conclude like this? Van Niel find that when water is there, oxygen is coming. When water is not there, oxygen is not coming. It means oxygen came from water. But it is an assumption. It is not experimental proof. So experimental proof for water give oxygen is given by Reuben, Kamen, Hasid and co-worker. Co-worker for that would be wrote a word ETAL. They got Nobel Prize for their work also. So they have taken the help of radioisotopes. So 6CO2, here they have taken O16. Normal oxygen have which molecular weight? Atomic weight, 16. It reacts with 12H2O. Here they taken the oxygen 18. So he changed the oxygen. In carbon dioxide, normal oxygen. In water, he have taken radio-labeled oxygen and performed photosynthesis in algae. What the outcome he got? C6, H12, O6 plus 6H2O plus 6O2. And he got O2 have O18. So who have O18? Water have O18, and who have O18? O2 have O18, means oxygen evolved came from which one? Photolysis of water. That is finally proved by experiment of Reuven, Kamen, Hasid and their co-worker, understanding the idea by using O18 as a radioisotopes. Got the idea? And for this discovery, he got the Nobel Prize also. So experimental verification of Van Niel's finding is given by Reuven, Kamen and Hasid. So who is over? Early experiment over. Now we are going to talk about the next paragraph of the NCERT, and where they ask, where does photosynthesis takes place? NCERT asks a question, where does photosynthesis takes place? Answer of this question is green part of plant. Why in green part? So it contains chlorophyll. In their chloroplast. Got the idea? Now if we talk about any example of green part of plant, leaves. Leaves is example of green part of plant. Got the idea? Green part of plant example is what? Leaves. So where in leaf photosynthesis occur? Where in leaves photosynthesis occur? Photosynthesis occur. So answer of this question is mesophyll cell. So mesophyll cell. So mesophyll cell in the leaf, mesophyll cell contain chloroplast. So why it occur in mesophyll cell? Because it contain chloroplast. Understanding the idea or not? Now if we talk about mesophyll cells, arrangement of chloroplast in mesophyll cell. Now what heading we are going to discuss? Arrangement of chloroplast in mesophyll cell. Give your attention. So suppose that this is a mesophyll cell. So in mesophyll cell, where chloroplast is present? So in mesophyll cell, chloroplasts arrange in periphery. Chloroplasts have peripheral arrangement. So I am writing in chloroplast, in mesophyll cell, chloroplast is present in periphery. chloroplast is present in periphery. Question arises why? There are two benefits. One reason, to absorb light. To absorb light. In periphery, who is there? More light is there. And second, gaseous exchange occur better when anything in periphery. So suppose that you are in your room and you want more light and more air. So you go near to the door or window, na? You got light also and air also. So in periphery, availability of light is also more, and in periphery, gaseous exchange also occur easily through atmosphere. And that is the reason chloroplast is arranged in periphery in case of which one? Mesophyll cell. Did you got the idea? Now I am telling you arrangement of chloroplast in mesophyll cell at different light intensity. So at different light intensity, arrangement of chloroplast in mesophyll cell is different. How? Try to understand. This is a mesophyll cell. This is a mesophyll cell at high light intensity. And this is the same mesophyll cell at low light intensity. Got the idea? What happened? When light intensity is high, arrangement of chloroplast in mesophyll cell is like this. Got the idea? And when intensity of light is low, low light intensity, arrangement of chloroplast in mesophyll cell is like this. Like this. So this is called radial wall. And this is called tangential wall. Same here. So what you are finding in case of high light intensity arrangement of chloroplast. So at high light intensity, chloroplast is parallel to incident light as well as radial wall. And perpendicular to tangential wall. So between tangential wall and pigment, what is the angle? 90 degree. And between the chloroplast and radial wall, what is the angle? It is parallel. So with this wall, it is perpendicular. Light is also coming like this. So it is parallel to light also. Are you getting the idea? Chloroplast arrangement is parallel to light. Chloroplast running like this, light is also coming like this. Understanding the idea or not? And what is the advantage of it? Advantage of it is when light intensity is high, Less number of chloroplasts exposed to light. Only who is exposed to light? These chloroplasts exposed to light. Huh? Only 2 chloroplasts exposed to light. Rest of the chloroplast is hidden in front of one. I am standing in the light and remaining people are like back me. So I am one chloroplast, remaining chloroplast is hidden by me. So what is the advantage of it? They adjust the entry of light. If intensity of light is more, they absorb less light. So they expose less number of chloroplast. They expose less number of chloroplast. When intensity is high, low, look na, intensity is low. So most of the chloroplast, so what happens at low light intensity? Chloroplast is perpendicular to incident light and radial wall. And parallel to tangential wall. So here they absorb more light because most of the chloroplast light is coming in this direction and chloroplast arranged in this direction. So which kind of angle is there? You see 90-degree angle is there. Understanding the idea or not? So they will absorb more light, here it will absorb less light. If it not happen, in this case it will absorb, if suppose that intensity is high and chloroplast arranged like this, then what happens? They absorb very high amount of light and what happens? Solarization or photooxidation occurs. Understanding the idea? So arrangement of the chloroplast in the mesophyll cell is different at different light intensity. I hope you understand about it. Is it clear? Now I am saying you about the chloroplast. Give your attention. So if we talk about chloroplast, we already studied in cell. It is surrounded by double membrane structure. And inside the chloroplast, there is a stack of membranous structure is there.